Okay, 4.3, the remainder and factor theorem. Now we're going to draw from some of the different concepts that you learned in Algebra 2. For example, we're going to start right away with divide 2x squared plus 3x minus 8 by x minus 2. State the quotient and remainder. So we're going to do this using long division. Set the long division up. We have x minus 2, and then 2x squared plus 3x minus 8. Again, to do long division, we want to try to match the first term up with the first term that is being divided by. So to do that, we're going to multiply by 2x. So 2x times x is 2x squared, and 2x times a negative 2 is minus 4x. And then we must subtract. So 2 minus 2 is 0, 3 plus 4, or 3 minus minus, which is a plus 4, is 7x. Bring down the minus 8. Now, what are we going to multiply that by to get 7x? That is a positive 7. So plus 7, 7 times x is 7x, and 7 times negative 2 is negative 14. So negative 8 plus 14 is a positive 6. Now before, we've done this with the rational. We had some end behavior asymptotes, specifically a slant asymptote. And the quotient, which is one of the things they ask us for, was our slant asymptote before. So the quotient, q of x, is the answer, 2x plus 7. Again, which happens to be what the slant asymptote was when we did previous sections. We're also interested in the remainder. When we were talking about the slant asymptote, we had no interest in the remainder. Now we are. Remainder is 6. So again, we're just reviewing what we've done in Algebra 2, what we've talked about earlier when we studied rational functions and end behavior using long division. Now let's take a look at the second example. Find f of 2 for fx equal to 2x squared plus 3x minus 8. So we're just going to substitute 2 in for x. So everywhere you see an x, we're going to put a 2. Okay, we can put this into the calculator. 2 times 2 squared plus 3 times 2 minus 8. And we get 6. Now, if you notice how these two problems were set up, this 6 happens to be the same as this 6. That's not just a coincidence. That was set up for a very specific reason. This basically defines the remainder theorem, one of the two big concepts we're going to be studying in this section. The remainder of the first we did long division was 6. The remainder of, by plugging a 2 into the same function, we get a 6. So where does the 2 come from? What we divided by. Okay, it's also right here. Okay, we have x minus 2. So we're seeing that this is the opposite number being put into the function. That's giving us the remainder. So we can now state what the remainder theorem is. The remainder theorem says if a polynomial p of x is divided by x minus r. So it must be of the form x minus r. The remainder is a constant p of r. So as you can see, we have x minus r. The opposite of that, positive r, is what we plug in to find the remainder. So a very simple way to find the remainder. We don't know the quotient, all we would get is the remainder. Okay, but when it comes down to breaking down larger polynomials into its factors, knowing the remainder is a very good start. We can then deal with the quotient at a later time. So let's take a look at another example. We're going to divide this out. Divide f of x equals x cubed plus 4x squared minus 3x minus 5 by x plus 3. We want to know the quotient and remainder, and then confirm the remainder by using the remainder theorem, finding f of negative 3. So let's first do the long division. So again, what we're looking at is what do we multiply x by to get x cubed? That is x squared. We take x squared times everything out front, so we get x cubed plus 3x squared. And then we subtract. X cubed minus x cubed is gone. 4 minus 3 is 1, x squared. Bring down to minus 3x minus 5. We multiply x by to get x squared. That's a positive x. X squared plus 3x. And then we subtract. X squared minus x squared is gone. Negative 3 minus 3 is negative 6x minus 5. What do we multiply x to get negative 6x? Well, negative 6. We get negative 6x minus 18. Subtracting, we get negative 5 plus 18, which would be a 13. So our quotient, q of x, is x squared plus x minus 6. The remainder is 13. We need to confirm the remainder by finding f of negative 3. If f of x is x cubed plus 4x squared minus 3x minus 5, then f of negative 3 would be negative 3 cubed plus 4 times negative 3 squared minus 3 times negative 3 minus 5. Or f of negative 3 would equal negative 3 cubed plus 4 times negative 3 squared minus 3 times negative 3 minus 5. 13. So we have confirmed that the remainder is the same if we use the remainder theorem just by finding f of negative 3. Again, we have no idea what the quotient would be if we didn't actually do the long division. And I agree, finding the remainder of 13 is a heck of a lot simpler by finding f of negative 3 than it is by doing this long division. So is there an easier way? If it's of the form x minus r, there is. And that is called synthetic division. If a polynomial is divided by x minus r, you can use synthetic division. So let's look at the example. Exact same one we just did. Okay, so take a look here. X cubed plus 4x squared minus 3x minus 5 divided by x plus 3. So let's set up the same way. Okay, now don't do long division. I'm just showing you the setup for long division so you to understand where the numbers are coming from for synthetic. Okay, synthetic division, we're going to make the exact opposite. Instead of going a division bracket, we're going to put a little half box, half bracket, however you want to call it. And what goes in that is the opposite of the number you're dividing by. So if it's x plus 3, you put negative 3 in that little half box. And then beside that, we're going to put all the quotients. So understood 1, 4, a negative 3, and a negative 5. Now, if there was a term missing, we would need to put a spacer in. Okay, you should always have one more coefficient than the degree. The degree of what we have here is 3, x cubed. Okay, so that's degree 3, so we should have 4 coefficients. If you have less than that, then you must have missed some spacers. For instance, if the x squared term was missing, then you would put a 0 in its place. Okay, but it's not, so let me bring that back. This would be synthetic division. Now, here's how synthetic division works. Put a little arrow and a bar. We're going to bring down the first number, 1. And then we're going to take that number times whatever's in the half box. So negative 3 times 1, and place it underneath the next number, negative 3. So negative 3 times 1 is negative 3. And then we add vertically. So 4 plus a negative 3 is 1. Then we take negative 3 times that 1. And we get negative 3 again. And then we add. We get negative 6. Take negative 3 times that negative 6 and get positive 18. And we add that. And we get 13, which happens to be our remainder. The exact same remainder we got in the last problem, as you can see right here at the top of the screen. We did the long division. What also we get out of this is the quotient. Okay, these numbers right here are the quotient. They are the coefficients of the quotient. Now, we divided once, so the quotient will be 1 degree less than what we started with. Since we started with x cubed, this will be 1x squared plus 1x minus 6, or q of x equals x squared plus x minus 6, and we know the remainder is 13. So we got the exact same answer as we did it earlier. Quotient x squared plus x minus 6, remainder of 13. But we did a heck of a lot less work. Multiply and add. Multiply, add, multiply, add. That's it. So if you are of the form x minus r, synthetic division is much, much faster than long division. And it gives you both the quotient and the remainder. Let's take a look at another example. All right, we're going to do this with synthetic division. So let's try to set it up without writing the long division. Do a little half box. What goes in that half box? Okay, not half, the opposite of that number. So we have a plus 1, we're going to put a minus 1. Now what's being divided? Well, x cubed, so that's our first coefficient, minus x squared, so minus 1. I don't have an x term, so I have to put a 0 for x, and then a 2 for the number. Again, the degree is 3. So we should have 4 coefficients. You should always have one more than the degree. Bring down the 1. We multiply. Negative 1 times 1 is negative 1. Add. Negative 2. Negative 1 times negative 2 is 2. Add. Negative 1 times 2, negative 2. Add. The remainder is 0. The quotient is x squared minus 2x plus 2. That is very important. When we get a remainder of 0, something special happens. That means that what we divided by goes into that polynomial evenly. There's nothing left. It's a remainder of 0. Okay, so we get two things out of that. That tells us that x plus 1 is a factor and the number, in other words, x equals -1, is an x-intercept on the graph. And that's what the factor theorem tells us. So if the remainder is 0, we're going to know that what we divided by is a factor, and that the number that is in the half box, what would happen if you set the factor equals 0 and solve, is an x-intercept of the polynomial.